All right, this is it. This is chapter 10. This is the king of the mountain. This is what you've been waiting for your whole life. You will never be the same after this. This is the moment where you become an adult, where boys become men, where girls become women. So, let's first talk about facts. Basic trig identities. A trig identity is a fact. You can use that fact to prove other facts are true. You can use these facts to make problems easier. There are 7 basic trigonometric identities, 4 of which you already know. We're going to review those. We will just rewrite them in a different form. The other 3 are known as the Pythagorean identities. So here's some ones that you know. For example, you already know that tangent of theta is the same as 1 over cotangent of theta. And we have discussed also that tangent of theta is sine of theta over cosine of theta. Now, the reason why we can say that tangent is the same as sine over cosine, if you recall back to the unit circle, everything relates to that. In a unit circle, the radius is 1. We have a y value, we have an r value. And let's say that theta is this angle here. We know that cosine of theta is x over r, which is x over 1, which is just x. We know that sine of theta is y over r, which is y over 1, which is y. Tangent, we know, is the opposite leg over adjacent leg, y over x. Sine is y, cosine is x. That's why this is equal to tangent. So these are 2 trig identities here, putting them as 1, but there's really 2 different ones. Tangent and cotangent are reciprocals, and tangent is equal to sine over cosine. Now, if you know that one, this next one should be pretty simple. Guess what cotangent of theta equals? Well, it's the reciprocal of tangent, so it's 1 over tangent. If tangent sine over cosine, that means cotangent of an angle is cosine over sine. Logical. Continuing. Secant of theta, we know, is the reciprocal of cosine, so it's 1 over cosine. Similarly, this implies that cosine of theta is 1 over secant of theta. The fourth one, cosecant of theta is the reciprocal of sine, so it's equal to 1 over sine of theta. That implies that sine of theta, I'm having trouble with thetas today for some reason, is equal to 1 over cosecant of theta. If we wanted to get real technical here, we have 1, 2, 3, 4, 5, 6, 7, 8 identities. But that could be condensed down to 4 or 5. I think nothing that we just discussed there is shocking to you because we've been discussing this in previous chapters. This next one is a Pythagorean identity. There are 3 of these. It says cosine squared of theta plus sine squared of theta equals something. Well, what does it equal? Well, I'm going to tell you, and that's going to make this an identity. Let's travel to the unit circle, shall we? Doesn't matter what quadrant we're in, we'll just make it quadrant 1 to be simple. So what do we know? We know that this is x, and this is y, and this is r. Everyone knows that. The Pythagorean theorem says that x squared plus y squared equals r squared. In a unit circle, by definition, the radius has to be 1. So I can replace r here with 1. Also, as we've discussed, let me not forget this is theta. We've discussed before that cosine of theta is x over r. That's x divided by 1, which is x. We can replace x in this equation with cosine of theta, because cosine of theta and x are the same thing. Let me space this out a little bit, give myself a little more room, like so. Likewise, sine of theta is y over r. R is 1. Y divided by 1 is y. So we could say this is plus sine of theta squared. We can simplify this a bit, and this is an important point here. Please note that this is cosine of theta. That's some kind of a function. This is sine of theta. It's some kind of a function. We're saying that we're squaring it. We can write it in a more compact way that looks like you're doing this in a different order, but you are not. So we read it as cosine squared of theta, but you do the operation cosine of theta, dramatic pause, and then you square it. Likewise, it's sine of theta squared, but you read it as sine squared of theta. So that means this first Pythagorean identity is cosine squared of theta plus sine squared of theta is 1. Typically, you will not see it written that way. It is written that way here for effect, that it's x squared plus y squared equals r squared. Typically, you will see it written as sine squared of theta plus cosine squared of theta is 1. It just comes off the tongue better. But those are the same identities. Just one has cosine written first, one has sine written first. That's Pythagorean identity number 1. It's the 5th overall identity that we're talking about today. Could be the 9th, depending on how you count. Next, this is the next Pythagorean identity. 1 plus tangent squared of theta equals secant squared of theta. And then it says verify this is true by starting with the first Pythagorean identity. So this is pretty easy to prove, actually. So cosine squared of theta plus sine squared of theta equals 1. That's the previous identity. For giggles, if I were to decide using the division property of equality, I'm going to divide all of these terms by the same thing. And the same thing that I'm choosing to divide them by is cosine squared of theta. Now this first term here, if you divide something by itself, well, you get 1. The second term, let's ignore the squareds for a second. It's just sine over cosine. Well, what's sine over cosine? Well, according to our first identity of the day, second, if depending on how you're counting, sine over cosine is tangent of theta. The fact that it's squared doesn't change anything when you're multiplying things together. So this is 1 plus tangent squared because this is squared and this is squared. That doesn't make sense, let me know and I can provide more explanation for that. And I might actually do that here regardless. Well, what is 1 over cosine? 1 over cosine is secant. This was squared, so this is also squared. We have just taken the first Pythagorean identity and showed you where this next one comes from. It comes from it. Let's do a little sidebar here just to explain why sine squared of theta over cosine of squared of theta is equal to tangent squared. Using properties of exponents, we could call this sine of theta over cosine of theta squared. And then sine of theta over cosine of theta is tangent of theta. And then that written in more condensed form is tangent squared of theta. I am not asking you to show this work, this right here. I'm just trying to show you why those things are equivalent. Number 7, which is the third Pythagorean identity. And you don't have to know the numbers, which is first, second, and third, but there are 3 of them. 1 plus cotangent squared of theta equals cosecant squared of theta. Verify it's true using this first trig identity, Pythagorean identity. So sine squared of theta plus cosine squared of theta equals 1. You can start out with cosine squared plus sine squared or sine plus cosine. Sine plus cosine is the more conventional. Well, what if this time I decide to divide each term by the same thing and I decide to divide by sine squared? The results will not shock you. Something divided by itself in the first term is 1. The next one, cosine divided by sine, is cotangent. And it's being squared, so it's squared. And 1 over sine squared is the same as cosecant squared. We just used, we used this identity to get this, and we used this little fella to get that part. So for now, you need to memorize these, I don't know, 8, 9, 10, 11 identities. It's called 7 on the paper, but there's really 11. I have them numbered. So this would be 9, and then this one's 10, and this one's 11. Let me tell you how important it is to memorize those. If on, let's just say for the homework for this, say I got 2 students. One student has these 11 memorized. The other student doesn't have it memorized, but uses their notes that has them all written down. The person that has it memorized will get their homework done in a third of the time that it will take the student who has their paper and is staring at it. That is without hyperbole. So memorize this. I suggest doing it before you even start your assignment. Well, let's see what kind of problems we're going to have to do in the homework. And once again, this is exciting stuff. Rewrite each of the following trigonometric expressions. So let me just remind you what an expression is. It means there's no equal sign. An equation has an equal sign, expression doesn't. Write them in terms of sine and or cosine and simplify completely. We're supposed to rewrite these, and our answer, the only trig functions we're allowed to use are sine and cosine. So to start this, you can do this in 1,000 different ways. As long as you come to the same conclusion, then we're going to be okay. So here's what I would suggest, especially early on. In most cases, not all, in most cases, rewrite the problem so that it's in terms of sine and cosine. For example, this says sine of theta, already in terms of sine and cosine. This says cosecant of theta. Well, we can change that. We can change that to 1 over sine of theta. And then we got minus cosine of theta. That's already in terms of cosine. I'm not going to change that. Tangent, that's not in terms of sine or cosine. What is tangent of theta equal to? Well, it's equal to sine of theta over cosine of theta. That's an identity that's on the front of your notes. Then, check this out. We are multiplying and dividing by cosine, so those cancel. That's going to give us sine of theta equals 1 over sine of theta minus sine of theta. We've already made it a lot simpler. Everything's in terms of sine. Are we finished? No. Completely simplify. Completely simplify means you shouldn't have any parentheses. I shouldn't say that. Yeah, I'm going to say that. Shouldn't have any parentheses. We have some. Using the distributive property of equality, I'm going to distribute the sine times each of these terms. Now, if I multiply sine times 1 over sine, those are reciprocals. If you multiply 2 reciprocals, you always get 1. 1 times a half, 2 times a half is 1. 38 times 1/38 is 1. 7/9 times 9/7 is 1. Multiplying 2 reciprocals always gives you 1. And then sine of theta times sine of theta is sine squared of theta. Now this looks pretty simple. And if you can get to this point in the problem, you're doing great, but there's actually one more thing we can do. And how we accomplish this can be done in a couple different ways. I'm going to show you one of those ways. This might rock your world the first time you see it, but you're going to get used to this real quick. This is side work. That's a fancy term that mathematicians use for work that's on the side. You can quote me on that. I'm going to take an identity that we know, or at least that I know, sine squared of theta plus cosine squared of theta equals 1. I'm going to manipulate it so I can see this in the equation, 1 minus sine squared. To do that, all I have to do is subtract sine squared from both sides using the subtraction property of equality for real numbers. This is the same as this, which means I can replace 1 minus sine squared of theta with cosine squared of theta. And that is completely simplified. You cannot get this any simpler. It's pretty cool, isn't it? I think so. Shall we do another? I think we shall. Number 2. When I see things that are squared, like I do in this, it immediately makes me think, maybe a Pythagorean identity would help me with this. You could also do it like we did the previous problem, change everything in terms of sine and cosine. here's what I'm going to do. I am going to take secant squared of x and replace it with what it's equal to in that second Pythagorean identity. Just take a look at it. It's 1 plus tangent squared of theta equals secant squared of theta. So I'm going to replace secant squared of theta with 1 plus tangent squared of x. Now, these parentheses aren't entirely necessary for this problem. I just wrote it for emphasis to show that I was substituting secant squared of theta with 1 plus tangent squared of theta. Now look what that does. That means we can subtract tangent squared of theta from tangent squared of theta. They cancel. They're inverse operations. We're adding and subtracting the same thing. Now we get 1 over cosecant of x. Can't leave our answer this way because the direction set has to be in terms of sine and cosine. Take a glance at the front of your notes. Front of your note says that cosecant 1 over cosecant of x is the same as sine of x. So that is as simple as it gets. Done. Let's do another. This one, I'm doing each of these problems slightly different than the previous one, just to show you have lots of options. If you're looking at this thinking, I know what you should do, change everything to sine and cosine, then it's absolutely correct. You can do that. But I did that for the first one that was like this. So this one I'm going to show you a little bit different. I'm going to distribute first. So we got this is going to be equal to cosine of theta times tangent of theta plus cosine of theta times cotangent of theta. Now I'm going to choose to change everything in terms of sine and cosine. So cosine of theta times, what does tangent of theta equal as regards to sine and cosine? Well, it's sine of theta over cosine of theta plus cosine of theta. I'm not changing it because it's already in terms of cosine. I'm going to change cotangent to cosine of theta over sine of theta. So what does this do for us? We're multiplying and dividing by the same thing in that first term, so they cancel. So now we got sine of theta plus, and this next one, we can't cancel anything. We can multiply. Cosine times cosine is cosine squared of theta. And then on the bottom, we just have sine of theta. So right now, everything's in terms of sine and cosine, but I don't believe this is simplified. For one, we have a fraction and a quote-unquote whole number in sine. Let's get common denominators. To do that, I'm going to multiply this fraction, sine of theta over 1, by 1 in the form of sine over sine. That's going to give me sine squared of theta over sine. All I'm doing is getting common denominators. Plus cosine squared of theta over sine of theta. Once you have common denominators, how do you add fractions? Well, you add the tops, you leave the bottoms the same. Now, what do you think we could do now? Look at the first Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1. Now, if the direction said simplify completely, and that was the entire directions, we would not be finished. So we can make this equal to cosecant of theta. But the directions say your answer should be in terms of sine and cosine and completely simplify. So using sine and cosine, this is as simple as we can make it, 1 over sine. Done. Let's do another. Number 4. Now I see something squared, so it makes me think Pythagorean identity. 1 plus cotangent of theta is the same as cosecant squared of theta. Now if you recognize that, this problem becomes super simple. We are dividing cosecant by cosecant squared, so we can cancel a cosecant of theta from the top and the bottom, which leaves us with 1 over cosecant of theta. That is not in terms of sine like the directions ask us to, so getting it in terms of sine would be sine of theta. Let's do number 5. Once again, immediately when I see this squared, I think Pythagorean identity. So if you take a gander at those, either in your brain or on your paper, we can replace this. We can replace it with cosecant squared of alpha. You don't need to write that part down. I'm just trying to explain as I go. So I can replace this with cosecant squared of alpha, and the bottom is cotangent of alpha. Oh boy, so what can we do now? Well, we could change things in terms of sine and cosine, which I'm going to do eventually. I'm not quite ready for that yet. You could choose to do that now. That's cool. I know that cotangent and tangent are reciprocals. So that means I can move tangent to the top because it used to be dividing by cotangent. Let me show you a longer version of that just in case that doesn't make sense, because that's rocks people's world sometimes. If you want to show this longer version when you're doing the problem, you can. It's not necessary. So if you recognize once again that cotangent is the same, hold on a second. If you recognize that cotangent is the same as 1 over tangent, we could do this. And then to get that, so it's not a complex fraction, we can multiply it by 1 in the form of tangent of theta over tangent of theta. So those cancel, and that gets us to the point that I had over there to the right. If this made sense to you, you don't need to write this down. If it didn't make sense to you, you should write that down. Once we get to this point, if I put my tangents together, tangent times tangent is tangent squared. Multiplying something by itself, it ends up being squared. Now at this point, I am out of ideas. I just need to change things in terms of sine and cosine. See what happens. Tangent squared of theta is going to be sine squared of theta over cosine squared of theta. Cosecant squared of theta is 1 over sine squared of theta. Cross cancel. We are multiplying the top and bottom by the same thing, so we can cancel those out, which leaves us with 1 over cosine squared of alpha. I might have said theta a second ago. It's alpha. Since the directions say the answer has to be in terms of sine and cosine, we have that, we're finished. Can't make it any simpler. If the directions didn't say put it in terms of sine and cosine, we could simplify this by making it secant squared of theta. Let's do 5 more examples. Rewrite each of the following trig expressions in terms of a single trig function. Now this doesn't say sine or cosine. It just means when we're finished, it should be one trig function. Shouldn't be any numbers or anything like that. I think it's just one trig function. So let's change it in terms of sine and cosine. That's usually good advice no matter what the directions say, and then see what happens from there. Doesn't mean we're going to leave it in those terms. So for example, secant of theta is the same as 1 over cosine of theta. Cosecant of theta is the same as 1 over sine of theta. Tangent of theta is the same as sine of theta over cosine of theta. So what happens next? What happens next is we are trying to subtract these two things, or to subtract two things and one of them is a fraction, you need common denominators. So this first fraction has a denominator of sine times cosine. So that means the second one, we're going to have to multiply the top and the bottom by sine of theta to get common denominators. So then we're going to have sine squared of theta over sine of theta cosine of theta. Once you have common denominators, which we do, you subtract the numerators, 1 minus sine squared of theta. Denominator stays the same. This is interesting, isn't it? Haven't we seen that before? We have. We've seen that back in our very first example, emphasizing this part right here. Sine squared of theta plus cosine squared of theta is 1. If you subtract sine squared from both sides, you get cosine squared of theta is 1 minus sine squared of theta. We're going to use that for this problem. So that top becomes cosine squared of theta. If you need to show that side work again, show it. If you don't, you don't. A lot of times you're required to show the side work. In a case like this, that fact is universally known. Don't need to show it. Then we can divide the top and bottom by cosine, which is going to leave us with cosine of theta over sine of theta. Now, if these were the directions on the front of the page, we'd be finished, because the front said leave your answer in terms of sine and cosine. These directions don't say that. These directions say write your answer as a single trig ratio. Well, guess what cosine over sine equals? It equals cotangent of theta. That's your final answer. Number 7. This problem is a mess. You can't see it right now, but boy, is it a mess. We are adding a bunch of fractions, which makes this a complex fraction. Now, the reason I can see that is because I've done these types of problems lots of times in my life. Let's change things into terms of sine and cosine, and you'll see what kind of mess we have. Secant is the same as 1 over cosine of your variable, plus cosecant of x is the same as 1 over sine of x, divided by 1 plus tangent of x may look a little bit familiar, but that is not a Pythagorean identity. 1 plus tangent squared is. This is not squared. So I'm going to change tangent, to sine over cosine. And I can't really do much with 1 at this point. This is a complex fraction. Or to simplify it, we need to make this one fraction on the top, make this one fraction on the bottom, and then make it not complex. So to do that, I'm going to take this first fraction on the top, you're going to get common denominators. I'm multiplying the top and bottom by sine. I'm going to fix this one by multiplying the top and bottom by cosine. I'm going to fix this 1 here by multiplying it by cosine over cosine. So that means my numerator is going to be sine over sine of x cosine of x plus cosine of x over sine of x cosine of x. I'm just trying to get common denominators in my numerator, trying to get common denominators in my denominator. Once you have common denominators, you add or subtract the tops, the numerators. So my numerator's numerator, that's a mouthful, we get sine of x plus cosine of x over sine of x cosine of x. The numerator or denominator is cosine of x plus sine of x over cosine of x. Once your numerator and denominator are one fraction, then we can once again try to make this not a complex fraction. Just to remind you, a complex fraction means you have a fraction in the fraction. So here's what we're going to do. We want to get rid of our complex fraction. So I'm going to multiply the top and bottom of the fraction by the reciprocal of the denominator. And you'll see what happens, at least I hope. There's other options besides doing this. Yeah, but let's just do this. You may see me do it different ways, different times. So what does this accomplish? Well, it gets rid of our denominator completely because cosine of x divided by cosine of x cancels. Cosine of x plus sine of x cancels with cosine of x plus sine of x. So what are we left with? We're left with sine of x plus cosine of x over sine of x cosine. I could have canceled some more things here in that last step, but I intentionally didn't. You are welcome to do so because I just don't want to do too much at once. It's your first time. We can cancel now. We are multiplying the top and bottom by cosine. Those cancel. Oh, well, check this out. This is sine of x plus cosine of x. This is cosine of x plus sine of x. They're the same thing. So that entire thing can cancel. But what are we left with? 1 over sine of x. Now this cannot be our answer because the direction said that the answer has to be a single trig ratio. This is a fraction that has a trig ratio in it. This can be simplified to cosecant of x. That is our final answer for that. Number 8. I'm going to change things to terms of sine and cosine at the very beginning. Secant of x is going to be 1 over cosine of x. Sine of x is already in terms of sine. Secant of x is, that's not right. Secant of x is 1 over cosine of x. Whoops. I'm going to show you a different way to do this problem also. I don't like how I started it. Cosine of x is the same as 1 over sine of x. So maybe don't write this down. I know you already started to, but I'm going to show you how this could be simpler. But I want to show you the long way in case you don't understand the shorter way. Now this fraction here, I don't want it to be complex. I'm going to multiply the top and bottom of the fraction by cosine of x, so those cancel. So that's going to give me 1 over sine of x cosine of x. You're still not writing this down. Okay, I'll tell you when to write down again. No, right. When I erase that, you can start writing. Over here, if I multiply the top and bottom by sine of x, those cancel, and I end up with sine of x over cosine of x. All right, so keep all that in mind. Did I write that right? Yeah, I did. Now, we could have accomplished all that in one step. So I'm going to put this under the no right, and let me explain. I mentioned this in a different problem. I mention it here again. Secant is on the top of the fraction. If I reciprocate it, that means I can throw it on the bottom and write down its reciprocal. What's reciprocal is cosine of x. See how it's the same thing we had down here? Likewise, secant of x is on the top. If I want to put on the bottom, I write its reciprocal. Its reciprocal is cosine of x. Cosecant of x is on the bottom. If I want to write it on the top, I got to write down its reciprocal, which is sine of x. Same thing I had down here. Dig it? So go ahead and write that down. This stuff here isn't that important unless you need it for your notes. This stuff here for sure is important. To subtract these two fractions, I need common denominators. So I'm going to multiply the fraction on the right, the top and bottom, by sine of x. It's going to give me 1 over sine of x cosine of x. Well, this looks familiar. Minus sine squared of x over sine of x cosine of x. Once you have common denominators, you subtract the numerators. Wow, that numerator looks familiar. Where have we seen this before? We saw it in the first problem we did, and we saw it in number 6. That is equal to cosine squared of x. That's Pythagorean identity manipulated a bit. We can then cancel a cosine from the top and the bottom. We still have one cosine on top. We have a sine on the bottom. Cosine over sine is nice and tidy, but the direction said a single trig ratio. That's 2 trig ratios. This is equal to cotangent of x. Done. We got 2 more. 2 more to do. Number 9. We could attack this with Pythagorean identities since the bottom has squareds in it. But I'm going to change this to terms of sine and cosine. Okay, so here's something I cannot do. I cannot take this and throw it on the bottom as cosine. You're thinking, why can't you? You did it on the previous problem. That's because this is being subtracted from something. I could take secant squared of theta and throw it on the top as cosine squared of theta because it's being multiplied on the bottom. But if you're subtracting things or adding things, you can't switch the place of them with the fraction. So I'm going to attack this problem by changing everything in terms of sine and cosine. So we got 1 over cosine of theta minus cosine of theta, and I'm going to change cosine theta to get common denominators. Cosine squared of theta over cosine of theta. My denominator I got sine squared of theta. I'm going to change secant to 1 over cosine squared of theta. It's going to give me 1 minus cosine squared of theta over cosine of theta divided by sine squared of theta divided by cosine squared of theta. Pretty complex fraction. This looks really familiar to me. Let me explain. This is side work. Sine squared of theta plus cosine squared of theta is equal to 1. If I subtract this from both sides, I'm going to get sine squared of theta equals 1 minus cosine squared of theta. Notice how things that are highlighted are the same. It means I can replace that with sine squared of theta. This is side work. If you choose to write it down, in a lot of cases you're required to. Actually, for now, you should just write it down. Put it off to the side. So I can make this sine squared of theta over cosine of theta divided by sine squared of theta cosine squared of theta. I want this not to be a complex fraction. So to fix that, I'm going to multiply by 1 in the form of cosine squared over cosine squared. So what does that do for me? These cancel completely because you're dividing the same thing by itself. And this cancels with one of these. So my numerator, I'm going to have sine squared of theta times cosine of theta. My denominator is sine squared of theta. You can divide anything by itself, which leaves us with a single trig function, what the directions ask for. All right, one last problem. This one's probably going to be the worst one. Oh, look, it is the worst one. This has lots of 1 plus things in it, which might make you think Pythagorean identity, but we can't use those because we don't have things that are squared. I'm going to start by getting common denominators. I'm not going to change things in terms of sine and cosine for this one, at least not here at the beginning. So to do that, this denominator and this denominator have nothing in common. You see the minus 1s? Things that are being minused aren't the denominator. This is all one thing. This is all one thing. So we need a secant of theta minus 1 over here. Multiplying it by the top and the bottom, same as multiplying by 1. We need a cosine of theta minus 1 over here, the top and the bottom. So what's that going to give us? We're going to have cosine of theta minus 1 times 1 plus secant of theta over cosine of theta minus 1 times secant of theta minus 1 plus 1 plus cosine of theta times secant of theta minus 1 over cosine of theta minus 1 times secant of theta minus 1. We have common denominators, so let's add the numerators together. Now I'm going to do that along with multiplying some things out. So for example, my denominator is this product. So I'm going to have a cosine times secant, distributive property, FOIL method if you will, and then minus a cosine of theta. I got negative 1 times secant, it's negative secant of theta, and then negative 1 times negative 1 is a plus 1. In my numerator, if I multiply this jazz together, we're going to have cosine times 1, cosine times secant, negative 1 times 1, negative 1 times secant, plus, now if this was a minus here, if this was a minus, I would have to put all the stuff in parentheses over here so I can distribute the minus, but it's not, so I don't need to. All that being said, I'm going to do it anyhow for emphasis because people mess that up all the time. Distributing, FOIL method, whatever you want to call it, I'm going to get secant of theta minus 1 plus cosine of theta secant of theta minus cosine of theta. Make sure that your fraction bar is big enough that you can see that everything that's supposed to be over and under the fraction is over and under the fraction bar. Okay, these parentheses right now that I have in this step of the problem are unnecessary, but I was just emphasizing the two different products. So guess what happens now? Look, we have a plus cosine of theta and a minus cosine of theta. Those cancel. Awesome. We have, let me write some of this down. So that's going to be, when those cancel, in the context of adding or subtracting when things cancel, we're left with a 0. Guess what this is equal to? Cosine times secant of theta. Those are reciprocals. When you multiply reciprocals, you get 1. I'm going to highlight things as we go. Bring down this minus 1. This minus 1 was from this fella. Oh, well, check this out. We have a minus secant of theta and a plus secant of theta. Those cancel. Then we have a minus 1 that's coming from this little fella right here. And then cosine of theta times secant of theta, that's a plus in front of it. Those are reciprocals. That gives us 1. Similarly, cosine times secant, reciprocals is 1. And then we got minus cosine of theta minus secant of theta plus 1. If I put my 1's together on the top, a plus 1 and a minus 1 and a minus 1 and a plus 1, it's 0. On the bottom, a 1 and a 1 is a 2. Minus secant of theta minus secant of theta. 0 divided by anything is 0. I forgot to mention these directions were a little different. So simplify the following trig expression, which means who knows what your answer is going to be, but you better make her simple. That concludes these notes. I hope you enjoyed it as much as I did, and you have yourself a nice day.